The scale is lying to you. Not about weight. It measures that correctly. It is lying about risk. Kristen Sahakian and colleagues followed 15,184 adults in NHANES 3 for a mean of 14.3 years. 3,222 deaths occurred in that window. Men with normal body mass index but central obesity, fat distributed around the abdomen and organs rather than dispersed across the body, had a hazard ratio of 1.87 for all-cause mortality compared with normal weight men without central obesity. Higher risk than men classified overweight, higher risk than men classified obese. The scale called them normal. Women with normal weight and central obesity carried a hazard ratio of 1.48 versus women with similar weight but no central obesity, 1.87. The scale said these men were fine. The 14-year follow-up did not. Visceral fat, the depot packed around the liver, pancreas, bowel, and portal vessels, is not the fat that weight measures. It is the fat that drives the blood work, the liver imaging, the fasting glucose, and apparently the mortality curve. That is the claim, and the evidence behind it has been building since 1990. The scale discussion already mapped why body mass index cannot distinguish lean mass from fat, and why normal weight central obesity can carry the worst mortality curve in the room. What that discussion did not do is explain the anatomy. Start there, because the confusion about why belly fat persists after weight loss comes from treating abdominal fat as one thing when it is two entirely different tissues. Subcutaneous adipose tissue sits under the skin. You can press it, you can pinch it. It is the layer that changes shape when you lose 20 pounds, and the face thins, and the arms thin, and the clothes fit differently. Visceral adipose tissue is behind the abdominal wall, packed around the liver. It wraps the pancreas, the bowel loops, the mesenteric vessels. You cannot feel it with your hands from the outside. Borga and colleagues documented the dissociation in 2012. Body weight and BMI cannot reliably tell you which depot is full and which is empty. The belt fits in the morning and bites by evening. The diet worked, the number moved, and the blood test is still wrong. That mismatch is not a mystery. It is anatomy. Per Bjorntorp was not working from imaging software or metabolic chambers in the modern sense. He was working from something older and harder. The clinical observation that fat distributed around the abdomen predicted metabolic disease in ways that fat elsewhere did not. He wanted a mechanism. In 1990, in arteriosclerosis, he produced one. The omental and mesenteric depots, the visceral fat, drain through the portal vein directly to the liver, not to the general circulation first, the way subcutaneous fat mobilizes, to the liver first. Those depots are unusually lipolytically active. They carry a preponderance of beta-adrenergic receptors and relatively little alpha-adrenergic inhibition, which means they release free fatty acids easily, readily, at a rate that subcutaneous fat does not match. Those fatty acids travel the portal route to hepatocytes. The liver answers by going wrong in exactly the ways the blood work later shows. Very low-density lipoprotein secretion increases. Hepatic insulin clearance is impaired. Gluconeogenesis from pyruvate, lactate, and alanine accelerates. The triad that characterizes metabolic syndrome, dyslipidemia, insulin resistance, elevated fasting glucose, appearing together in the same body, driven by the same depot. Lee and Kim in 2024, and the review literature before them, established that visceral adipose tissue secretes interleukin-6, TNF-alpha, resistin, and leptin into the portal circulation, while adiponectin falls. Visceral fat is not a passive storage site. It is an organ. It communicates with the liver all day through the portal vein. The fatty liver discussion already traced this from mesenteric fat to hepatocyte VLDL secretion. Bjorntorp described the architecture of that communication in 1990. It has held up for more than 30 years. You now know where visceral fat sits and where its signal drains. The question changes from whether this fat is dangerous to what specifically moves it. The first answer comes from pigments. Tetsuya Takagi and colleagues at Nagoya University of Arts and Sciences published a randomized, double-blind trial in Nutrients in 2020. 28 middle-aged Japanese men, age 40 to 64, all with body mass index of at least 25, assigned to one of 4 daily 400-gram vegetable paste beverages before breakfast for 8 weeks. 4 groups, 2 variables, high or low lycopene carrot, high or low lutein kale versus shibuki cabbage. Every group showed a decline in visceral fat levels by week 8. The high lycopene plus low lutein group moved from 14.8 down to 14.0. The high lycopene plus high lutein group from 15.2 down to 14.2. The low lycopene plus high lutein group from 14.6 down to 13.8. The low lycopene plus low lutein group from 17.0 down to 16.4. 24 men completed the study, not 28. Single center, 8 weeks. Dietary fiber and behavior change related to study participation could have contributed. Takagi and his co-authors named those limits explicitly. The script should too. Carotenoids, the molecules that make carrots orange, tomatoes red, sweet potatoes deep amber, bell peppers bright, and spinach dark green, even when chlorophyll partially hides the yellow-orange signal underneath, are antioxidants and signaling molecules entering a tissue environment already defined by oxidative stress, adipocyte dysfunction, and inflammatory excess. Matsumoto and colleagues in 2021 examined 805 Japanese adults in a cross-sectional design and found serum lutein, beta-carotene, beta-cryptoxanthin, and total carotenoids inversely associated with visceral adiposity, particularly in women. The mechanistic language from cell and animal literature points toward PPAR signaling pathways and oxidative stress reduction. Not dissolved, not melted, shifted. A tissue environment less favorable to fat storage and inflammation. That is the honest version. And what Takagi's groups actually ate. Not supplements, not extracted lycopene in capsule form. Blended carrot, kale, and cabbage, 400 grams before breakfast. Orange and dark green food every day for 8 weeks. You now know what the pigments in orange and dark green plants do inside the depot, at least in the direction the evidence points. The question changes from which vegetables to which molecule has stronger human intervention data behind it. Green tea, specifically catechins, flavonoid polyphenols concentrated in the leaves before processing destroys them. Tomonori Nagal, Tadashi Hase, and Ichiro Tokimitsu at the Healthcare Food Research Laboratories of Kao Corporation in Sumida-ku, Tokyo, published the Anchor Trial in Obesity in 2007. 2-week run-in period first, then multi-center randomization, stratified by sex and body mass index. The bottles carried codes, not product names. 240 subjects completed the protocol. 123 in the catechin group, 117 in control. Both groups drank green tea. One group received 583 milligrams of catechins per day. The other received 96 milligrams. 12 weeks. Subjects maintained their usual diet and physical activity. The catechin group showed greater reductions across every measure Nagal tracked: body weight, BMI, body fat percentage, body fat mass, waist circumference, hip circumference, visceral fat area, subcutaneous fat area, systolic blood pressure in participants whose baseline was 130 or higher. LDL cholesterol, visceral fat area specifically responded, not just total weight, the specific depot. The green tea discussion already separated the established human catechin trials from the more speculative lipase inhibition mythology. The mechanistic story involves increased fat oxidation and thermogenesis, possible interference with intestinal lipid handling, and a likely synergy between catechins and the caffeine naturally present in green tea on sympathetic nervous system activation. What the Nago trial gives you is something different from mechanism. A blinded, multi-center, randomized result in 240 adults, showing visceral fat area responding to a specific catechin dose over 12 weeks. 583 milligrams, not whatever happens to be in a randomly chosen tea bag. Matcha and sencha generally preserve more catechins than heavily processed or diluted bottled teas. The trial tested a standardized dose, not a brand promise. You now know what 583 milligrams of catechins does to visceral fat area over 12 weeks. The question changes from which molecule targets the depot to which physical force attacks it directly, and not any exercise at any intensity. In 1997, published in Diabetes Care, Morier and colleagues assigned 24 patients with non-insulin-dependent diabetes mellitus, mean age 45, mean body mass index 30.2 kilograms per square meter, to training or sedentary arms. The training was not theatrical. 45 minutes of supervised cycling at 75% of oxygen uptake peak, twice per week. 1 intermittent session per week. 2 months. VO2 peak rose 41%. Insulin sensitivity improved 46%. Then MRI at the level of the umbilicus. Visceral adipose tissue fell approximately 48%. Subcutaneous adipose tissue fell approximately 18%. Body weight did not significantly change. The dangerous depot dropped nearly in half. The scale barely noticed. 24 patients, 2 months, cycling. Visceral fat down 48%, while the scale showed almost nothing. Verhegen and colleagues confirmed the pattern at scale in obesity reviews in 2016, 117 studies, 4,815 participants. Diet caused larger total body weight loss. Exercise showed a tendency toward a larger visceral fat decrease. In the absence of any weight loss at all, in studies where body weight did not change, exercise was associated with a 6.1% reduction in visceral adipose tissue, while diet showed virtually no change, approximately 1.1%. Diet moved the scale, exercise moved the dangerous fat. Those are not the same event. You now know that exercise attacks visceral fat even when the scale does not register the attack. The question changes from whether to exercise to what intensity actually crosses the threshold visceral fat responds to, because low-intensity movement on the available evidence does not cross it. Vissers and colleagues examined this directly in PLOS One in 2013. Moderate intensity, 60 to 70% of maximum heart rate, or 45 to 55% of VO2 max, produced a significant visceral fat reduction. High intensity, above 70% of maximum heart rate, also produced a significant reduction. Low intensity produced no significant effect. The threshold exists. The insulin resistance discussion already mapped how AMPK deactivates TBC1D1 and pushes GLUT4 to the membrane during muscle contraction. The cellular machinery that makes moderate to vigorous exercise metabolically distinct from gentle movement is the same machinery that changes what happens to the visceral depot over time. Chang, Yang, and Shun pushed the intensity question further in the International Journal of Obesity in 2021. Using a network meta-analysis of randomized trials, high-intensity interval training and aerobic exercise of at least moderate intensity were both beneficial. 3 sessions per week for 12 to 16 weeks, 30 to 60 minutes per session for aerobic exercise. Xiao K. Chen and colleagues pooled 84 randomized controlled trials in obesity reviews in 2024. 4,836 participants. Aerobic exercise, resistance training, combined training, and HIIT all improved visceral adipose tissue, but probability rankings favored vigorous intensity, aerobic exercise, and HIIT. Resistance training least effective specifically for VAT. That does not mean resistance work is useless. It means the modality ranking for this specific depot is not ambiguous. Maillard's 2018 meta-analysis found mixed head-to-head results between HIIT and moderate continuous training. 6 studies favored HIIT, 3 found equivalent effects, 3 found no significant difference. The honest summary: the intensity threshold matters more than the modality. Moderate to vigorous crosses it. Low intensity, on current evidence, does not. Now the pharmaceutical version, because the comparison is instructive and the dose difference is honest. An obesity or diabetes specialist, a prescription pad, dose titration across several weeks, injection training for subcutaneous administration, lab monitoring at intervals, CT or DXA imaging to confirm whether visceral fat specifically fell. Liu and colleagues in cardiovascular diabetology in 2014 gave liraglutide to 31 patients with type 2 diabetes on top of existing metformin and oral agents. 12 weeks. Then measured body composition by DXA and abdominal fat areas by CT. Body weight, waist circumference, total fat, lean mass, subcutaneous adipose tissue, and visceral adipose tissue all fell. The infrastructure behind it, the specialist, the prescription, the titration schedule, the injection, the monitoring, the imaging hardware, the CT reconstruction, the technicians, the clinicians, and the weeks of follow-up. The surgical version adds anesthesia, an operating room, a stapling device, hospitalization, a recovery period, and years of nutritional surveillance. GLP-1 receptor agonists and bariatric surgery produce larger total weight loss than tea and exercise alone. That is the honest comparison. The biology they exploit: appetite regulation, fat mobilization, liver metabolic load, energy substrate handling, is the biology the body already owns. The difference is dose and mechanism of delivery, not the existence of a separate system. Here is where each mechanism sits and what that means for how confident to be. Visceral fat is metabolically dangerous. Portal drainage to the liver, beta-adrenergic lipolytic activity, hepatic VLDL secretion, inflammatory adipokine secretion. Bjorntorp described it in 1990, and it has replicated across decades. Exercise reduces visceral adipose tissue. Established. Vissers 2013, Verhegen 2016, Shang 2021, Shen 2024. Independent meta-analyses converging on the same direction. Moderate to vigorous aerobic exercise and high-intensity intervals most effective for VAT specifically. Strong but not absolute. Chen's probability rankings are suggestive. Maillard found mixed head-to-head results. Catechin-rich green tea reduces visceral fat. Plausible to strong. Nagao's 2007 trial is real. 12 weeks, 240 subjects. The mechanistic lipase inhibition and thermogenesis claims are stronger in preclinical than direct clinical imaging literature. Carotenoid-rich vegetables reduce visceral fat. The most cautious claim, Takagi 2020, is small, short, fiber confounded. Matsumoto 2021 is cross-sectional. The safe language is association and directional effect. Not mechanism-confirmed reduction. Not established. Directional. 1.87. That number should not leave this essay without its full consequence named. Sahakyan and colleagues. N. Haynes 3, 15,184 adults. Mean follow-up 14.3 years. 3,222 deaths. Normal weight men with central obesity. Hazard ratio 1.87 versus normal weight men without central obesity. Higher than overweight, higher than obese by BMI alone, in some comparisons, where hazard ratios of 2.24 and 2.42 appeared. The study was observational. Waist-to-hip ratio as a proxy, not CT-measured visceral fat. Causality cannot be inferred. What it proves is the story problem this essay is built on. Body weight alone can call a person normal, while they carry the metabolic phenotype with the worst long-term survival in the dataset. The scale called them normal. The 14-year follow-up did not. Both food levers in this essay, the carotenoids and the catechins, arrived as compounds in ordinary dietary objects before the metabolism industry isolated them into labels. Takagi's trial used blended carrot, kale, and shibuki cabbage. Nagao's trial used green tea. before anyone standardized the catechin dose or measured lycopene content in a controlled condition. These were cups and leaves and roots and chopped vegetables. The same culture that produced both blinded trials, Japan, where green tea is a background condition of daily life, and where vegetable consumption patterns differ from industrialized Western diets, did not begin with pills. It began with food patterns that science then tested to see whether the molecules those patterns delivered could survive the machinery of randomization and blinding and produce a measurable result. Enough of them did. The tea is not negotiable in the morning. That is not a discipline statement. The 583 milligrams in Nagao's 2007 trial is a number I have not been able to argue with in several years of reading. The protocol that follows from the evidence is specific and unglamorous. First meal of the day contains a carotenoid anchor every day, visible orange, red, or dark green on the plate. Carrots, tomatoes, spinach, bell peppers, squash, sweet potato, kale. Enough that the plate is not beige. Green tea follows daily in a preparation that preserves catechins, matcha or a well-brewed sencha rather than a diluted bottled product. 2 to 3 cups is the practical target, knowing that the trial standardized at 583 milligrams and that catechin content varies considerably by preparation method and leaf quality. Exercise runs 3 sessions per week for 12 to 16 weeks minimum. 2 of those sessions are 45 minutes at 70 to 80% of maximum heart rate, the talk test range, where full sentences are still possible but require effort. The third is intervals, if joints and preference allow, or a third continuous session if they do not. Cycling, rowing, uphill walking, running, swimming, dancing, the modality matters less than the intensity threshold and the accumulated dose over 12 to 16 weeks. Week 1 produces mostly disappointment. The abdomen has not changed. The scale has not changed. The cardiorespiratory system is negotiating the demand. Week 4 is where the talk test gets easier at the same pace, and waist measurements sometimes begin to separate from body weight. Week 8 is where Morier's result becomes psychologically important. The scale may still be unimpressed, while the body is materially different. The one contraindication, unstable cardiovascular disease, uncontrolled hypertension, or orthopedic limits that make vigorous exercise unsafe, require medical clearance before forcing intensity. That is not a liability disclaimer. It is the reality that this audience, a decade or more of sedentary accumulation behind them, may have conditions that change the calculus. Return to the beginning. The belt fits in the morning and bites by evening. The diet worked, the number moved, and the blood work was still wrong. Now you have the vocabulary for what was happening. Visceral adipose tissue, sitting behind the abdominal wall, draining through the portal vein to the liver, secreting fatty acids and inflammatory signals at a rate subcutaneous fat does not match. Bjorntorp maps the portal route in 1990. Sahakian showed the mortality consequence across 14 years and 15,000 adults. And the inputs that change the depot are not exotic. Carotenoids shifting the redox and signaling conditions in the adipocyte environment. Catechins at 583 milligrams per day, producing visceral fat area reductions in a 12-week blinded trial. Exercise at moderate to vigorous intensity, producing a 48% visceral fat decline in Morier's 2-month MRI study, while the scale showed almost nothing. Verhegen put the number plainly. Diet reduced visceral fat by 1.1% in the absence of exercise. Exercise reduced it by 6.1% in the absence of weight loss. Not equivalent levers, different targets. The scale measures what you weigh. It's never measured what is killing you.